Okay, today we will be talking about fundamental identities of trig. So in the first, we are talking about the Pythagorean trig identity, which is sine squared theta plus cos squared theta is equal to 1. And it is valid based on the Pythagorean theorem only because sine is considered as the y-axis and cos is the x-axis. So based on this one identity, I can derive more identities because if you subtract cos squared theta, what will happen if you subtract sine squared theta both sides? So if you understand only one identity, sine squared theta plus cos squared theta is equal to 1, which is nothing but y squared plus x squared, or x squared plus y squared is equal to the hypotenuse squared, we can derive series of identities. Now, if on the basic identity, sine squared theta plus cos squared theta is equal to 1, if I divide both sides by sine squared theta, we will get another set of identities. Now, sine squared theta and sine squared theta will cancel out. So that will be 1. And then we know cos over sine is cot squared theta. And 1 over sine is cosecant squared theta. Now with this new identity, I can derive few more just by manipulating them. So as you can see on the right hand side, I'm writing more identity based on 1 plus cot squared theta is equal to cosecant squared theta. We can have one more. Now let's do the other way. So we have sine squared theta plus cos squared theta is equal to 1. That is our basic identity, right? So instead of dividing this identity, Pythagorean identity, with sine squared theta, let's divide by cos squared theta. So as you can see, sine over cos is tangent squared theta, and then cos and cos will cancel out, that is plus 1, and 1 over cos is secant squared theta. So we derived another identity, and with this identity, we will have another set of identities just by manipulating tangent squared theta plus 1 is equal to secant squared theta. Now, these are all the sets of identities we derived from one basic identity, sine squared theta plus cos squared theta is equal to 1. And these will help us to solve these type of problems. So remember, always use the algebraic approach to prove that the two expressions are equivalent. Before we start to prove that the expressions are equivalent, let's understand how to simplify them. So in this particular example, we have cos squared x times cosecant x minus cosecant x. So we can see cosecant x is common. Can I factor out cosecant x? So let's factor it out. We will be left with cos squared x minus 1. And this is one set of the identity that we derived earlier. So because sine squared theta plus cos squared theta is equal to 1, cos squared theta minus 1 will be sine squared theta. And I know cosecant is nothing but 1 over sine, so we can rewrite 1 over sine x times sine squared x. Now sine squared x implies sine x times sine x. So 1 sine x will cancel out. The only answer that is left is sine x. Let's take one more example. Okay, this time we have now they want to use the value tangent theta is given as 1/3 and cos x is less than 0. Now just by looking at cos x is less than 0, on the unit circle where the x value is less than 0, either in quadrant 2 or quadrant 3. But it also says tangent theta is 1/3. That means tangent is positive. Tangent is positive in quadrant 1 and quadrant 3. So the quadrant that we are looking for is only quadrant 3. Because for cos 2 and 3, for tangent 1 and 3, common is quadrant 3. We know tangent theta is nothing but sine theta over cos theta, so which is 1 over 3. That doesn't imply that the sine theta is 1. No, because we are cancelling out the hypotenuse as well, right? So our line of action is towards quadrant 3. So we know that secant square theta is equal to 1 plus tangent square theta. And we know tangent theta is 1/3. Let's plug the value of tangent. So 1 plus 1/3 squared, that will give you 10 over 9. And if I take radical both sides, we will get secant theta is equal to radical 10 over 3. Right, so we know that secant theta is radical 10 over 3, but we are talking about quadrant third, it will be negative. Because cos is negative in quadrant 3, and because cos is negative, secant will also be negative. So we can say cos theta is 1 over secant theta, and we can have negative 3 over radical 10, but we don't like radical the denominator. After rationalizing it, you are getting negative 3 radical 10 divided by 10. Now sine theta, I can manipulate sine theta as sine theta times cos theta divided by cos theta, because cos theta divided by cos theta is just 1, but it will help me because now I have sine theta over cos theta, which is nothing but 1/3 that is given, and we just calculated cos theta as negative 3 radical 10 over 10. So fundamental identity, solving it, it is just manipulating the given identities, manipulating the basic information, the quotient identity, product identity, and getting the things done. So cosecant theta is 1 over sine theta. That will give you, again, don't forget to rationalize. That will give you the answer as negative 10 over radical 10. Rationalize it. Negative radical 10. Let's take one more example. Now, yes, sorry about that. Example 3. Now, in this case, they want us to use factoring. Now, in this problem, let's use u sub. So let u is equal to cosecant theta, because this equation is in the format of ax squared plus bx plus c, which is a quadratic. So after this, we are getting a quadratic, and it is easier for us to factor it out. If you factor it out, you will get 2u minus 3 and u minus 2. After this, replace u with cosecant theta. And that will be the simplified form, the factored form. So you need to look at the pattern. You need to see how the expressions are given, and if I can factor it using quadratic. So this is in the format of ax squared plus bx plus c. Moving forward, let's take one more example. Example number 4. Another type of factoring. Now, as you can see, we have secant and tangent x. I cannot use u sub. I cannot say let u is equal to secant, but I can rewrite secant squared x. So we just discussed the identities at the start of the video lesson. So I know secant squared theta is 1 plus tangent squared theta. Instead of theta, they are using x in this case. And now we can simplify it further, and it looks like a quadratic. Tangent squared x plus 3 tangent x plus 2. At this point of time, I can use u sub. So let u is equal to tangent x. So u squared plus 3u plus 2. And then start factoring. Replace u. Tangent x plus 2 and tangent x plus 1. Okie dokie. Let's take one more example. Example 5. Now, if we have two fractions and we need to add them. So we have 1 over 1 plus sine theta and plus 1 minus sine theta. So the same way you add fractions, you need to make a common denominator, right? I will use the same principle of adding the fractions. Common denominator. So can I multiply the first equation, the first fraction by 1 minus sine theta? Because that is the denominator of the second fraction. And multiply the second fraction with the denominator of the first fraction, which is 1 plus sine theta. Right? If you simplify it, you will get 1 minus sine theta plus 1 plus sine theta. And in the denominator, we will get 1 minus sine theta times 1 plus sine theta. That is nothing but a squared minus b squared. Right? So whatever we have learned previously, we are bringing everything together. So 1 minus sine theta, 1 plus sine theta will be equal to 1 minus sine squared theta, because 1 squared is 1 only. And what is 1 minus sine squared theta? Go back to the Pythagorean identity. 1 minus sine squared theta is nothing but cos squared theta, because cos squared theta plus sine squared theta is equal to 1. And whenever we have cos squared theta in the denominator, that becomes a secant squared theta. There you go. This is our lovely answer. Let's continue with this. Let's take one more example. Now they want you to rewrite not in the fractional form. So expression is given and I need to rewrite so that it is not in a fraction form anymore. So we have cos squared theta divided by 1 minus sine theta. So can I rewrite cos squared theta as 1 minus sine squared theta? And what is 1 minus sine squared theta? That is in the form of a squared minus b squared. Let's rewrite it. 1 minus sine theta times 1 plus sine theta divided by 1 minus sine theta. And then at this point, I can cancel out numerator and denominator. So what we are left with? We are left with 1 plus sine theta, and 1 plus sine theta is not in the fractional form. So work is done. Let's continue and take one more example. Okay, this time, let's see. Now they want to use the substitution. So they have already given you the substitution, what you need to substitute. And the substitution is x is equal to 4 secant theta. So it implies if there is any x, replace that with 4 secant theta, provided theta is greater than 0 but less than pi over 2. And they are asking us to rewrite radical of x squared minus 16. So it says that x should be replaced by 4 secant theta, right? So let's replace x. So if I replace x, that will be 4 secant theta squared minus 16. Now what is 4 secant theta squared? That will be radical of 16 secant squared theta times 16. At this point, I can factor out 16, and we are left with secant squared theta minus 1. If you go back to the identities, secant squared theta minus 1 is nothing but tangent squared theta. See, secant is related to tangent and cosecant is related to cot. So my final answer will be 4 tangent theta. One more happy chappy answer. Now, let's understand one more. Now, in this case, we are combining ln with the trig. So we have ln of secant x and ln of sine x. You need to remember that ln of m plus ln of n will give you ln of m times n. That is a property. Adding implies multiplication, subtraction implies division. So we can combine them. And what is secant x? Secant x is 1 over cos x. And sine x over cos x will give you tangent x. That is your rewriting form. After this, let's talk about something called verifying the trig identity. So we know how to simplify it. Now, verifying the identity. To start with the verifying the identity, a few things we need to keep in mind. Let's discuss about it one by one. You need to keep in mind that you are not solving an equation. Then only work on one side, either left hand side or right hand side. Then use trig identities and further we can work on both sides simultaneously, but you need to be very, very careful that we are not combining the right hand side with the left hand side. They need to be worked with totally independently. Sometimes when the expressions are quite long, it is a good idea to work on both the sides. But always try to work on one side and try to prove to the other. If that doesn't work, then yes, you can work on both sides. Let's take one example. We have secant x times cot x, and they want us to prove to cosecant x. So on the right hand side, we just have one term. So let's simplify the left hand side. We can rewrite secant x as 1 over cos x and cot x as cos x divided by sin x. And after that, you can see I can cancel out cos x. We are left with 1 over sin x, and reciprocal of sin x is nothing but cosecant x. You can see I'm not writing anything on the right hand side because I can just bring it down. It will just save your time. Let's continue. Let's take one more. We have 1 minus sine squared x over sin x is equal to cos x times cot x. Pause the video, try to simplify it again, and then check the answer. So, what we are looking for, 1 minus sine squared x is nothing but cos squared x. And then, so cos squared x divided by sin x, it should be sin x, not sine squared x. And then cos squared x is nothing but cos x times cos x. Let me correct this one. Yeah, sin x. Now, we can say cos x divided by sin x is cot x. And then cos x is just hanging in there. And that proves that the right hand side is equal to the left hand side. Done, game over. Let's take one more. Now we have secant squared x minus 1 times sine squared x minus 1 is equal to negative sine squared x. Again, pause the video, try to verify it again on your own, and then check the answers with me. We know secant squared x minus 1 is tangent squared x, and sine squared x minus 1 will be negative of cos squared x, right? So if we simplify it, tangent squared x can be written in terms of sine and cos. And then we can cancel out cos. We are just left with negative of sine squared x. Negative sine squared x. Let's take one more example. Now this time, we have tangent squared theta divided by 1 plus secant theta, and they want it to be equal to 1 minus cos theta over cos theta. Again, the drill is the same. Pause the videos, do it on your own, and then come back and check the answer. So I can rewrite tangent squared theta as secant squared theta minus 1 over 1 plus secant theta. And secant squared theta minus 1 is nothing but a squared minus b squared. So which is secant theta plus 1 times secant theta minus 1. And then we can cancel out secant theta plus 1 with 1 plus secant theta in the denominator. and secant theta is 1 over cos theta. And if I simplify that fraction by making the common denominator, we will get the same thing. Rewrite it 1 minus cos theta divided by cos theta, which is equivalent to your right side of the equation. One more time, we were able to prove it. Let's continue. Let's take one more example. It's fun to solve these. Now we have cube. Sine cubed x cos to the power of 4x. Then on the other side, we have some powers. Now it is a good decision to solve the right hand side in this case. So try to solve the expression that is a little bit longer. I can factor out cos to the power of 4x, and we are left with 1 minus cos squared x. And you know 1 minus cos squared x is nothing but sine squared x times sine x. Now we have sine squared x times sine x. Remember, when the terms are multiplied, their power adds up. So sine cubed x times cos 4x, that is the same as the left-hand side of the equation. And we were able to prove one more time. So practice these questions. They are fun. They are very satisfying. And I will see you in the next video. Bye-bye.